Friends, welcome to Code Sutra. In fact, this is the first problem that I have solved on this particular channel about a month ago. In this video, I'll be discussing about LeetCode problem number 1011, capacity to ship packages within D days. The approach to this particular problem might not be very intuitive, but once you understand this problem, right, you will be able to solve straight away 6 to 10 problems on LeetCode or any other problem. Okay, the idea of this channel is to discuss a pattern rather than just solving a problem. So without further ado, let's get into the code. In this problem, you are given port A and port B, okay, and you have a ship in between. You have to ship all these weights from port A to port B within the given number of days. In this problem, 1, 2, 3 and 4 are the given weights, and you have to shift all of these weights in the two days. And what is the minimum capacity of the ship to do so? For example, you can decide to ship like this. First day you can ship one weight. The second day you can ship all the other three. Then what is the capacity of the ship? The capacity will be 9. So the second approach is you can ship first 2 elements and the remaining 2. That is 3 and 7. So the capacity will be 7. That is the maximum out of these two. That is 7, right? So similarly, you can decide to shift all these 3 on day 1 and 4 on the day 2. So what will be the capacity then? The capacity will be 6, right? Because the maximum of these two. And that is our required answer. So if you look here, the capacity was 9, 7 and 6. What is the minimum of all this? That is 6, right? So what are the quick observations that we can draw here? Let's look at this. So what is the minimum capacity of the ship that you want? It is 4, right? That is the maximum weight. Your ship can never be lesser than this. Even if I give here 10 days, can the capacity of the ship be any lesser than that? No, right? Because you have to carry 4. So that is the first observation, that the minimum quantity of the ship will be the maximum weight. And the second one is, I will just give you 1 day. Okay, then what will be the quantity? It will be 10, right? Because you will be shifting all of these weights together. Right? So we know now the range. The range is 4 to 10. Why? Because 4 is the minimum quantity of the ship. That is the maximum weight. That is, even if I give 10 days or 20 days, you have to shift the maximum weight. So that will be the minimum range. And what is the maximum? The maximum will be the sum of all the elements. That is 10. So we know the minimum range. Now we know the maximum range. What we will be doing here? Now once we know the minimum range and the maximum range, let's pick a random element. For example, let's pick the mid element only, 7. Is it possible to shift with weight 7? Yes, we saw here, right? It is possible to shift with weight 7. So if it is possible to shift with weight 7, do you even want to check 8, 9 and 10? No, right? Because you can shift it with 7 only. The capacity of the ship can be 7 only. Then why do you want to check with 8, 9 and 10? So can this be marked with red and can we remove that part? Yes, we can do that. So let's pick another random number. Let's pick 5. Is it possible to shift in 5 days? No, right? It won't be possible. Because why? Because we can shift 1 day, 2 day. It will be taking 3 days. We'll be not be able to shift in 5 weight. If the capacity of the ship is 5, we cannot do that. So can we easily remove both 5 and 4? If it is not possible with 5 only, will it be ever possible with 4? No, right? We can easily remove this part as well. So that is the idea of binary search. We'll be picking up the mid element and we'll be eliminating the search space. For example, what I said is, if it is 8, we can eliminate all the elements greater than 8. Similarly, if it's a lower number, we can eliminate all the numbers lesser than that. So that is the idea. So how do you do this? This is what I have explained this. Initially, the left will be 4, the right will be 10. We'll be picking up a middle element, that is 7. So is it possible with 7? Let us check it. See, for now I will come to the implementation of this part, how to check this. But for now, think there is a magical function that will say you yes or no. Okay. So we will check with 7. The output will be yes, you can actually shift this. So we will be eliminating all the other 3. So once we eliminated all the other 3, our new answer will be equal to 7, right? Because you can shift with 7, that will be our new answer. And once you can shift with 7, our left or our right will change to 6. Now what is the new mid? 6 plus 4, that will be 5. Can we shift with 5? No, we cannot shift with 5. So similarly, both of them now will point at 6. So now what is our new mid? Our new mid will be 6. Is it possible with 6? Yes, it will be possible with 6, and we will update our new answer. I will come to the pseudocode of both of the problems. Okay, so let's get into the magical function. I was talking about the magical function, right? That will say whether you can shift within d days or not. So let's get into this magical function. So how do you implement this? For example, you are given 5 days and the weight is 18. What we will be doing is, first, whatever we can send in day 1, can we include the ship first weight? Yes. Can we include the second in the same day? The weight is 3. Let us write the current weight of the ship. Current weight and current required days, that will also be equal to 1 actually, because you need at least 1 day, right? And the current weight will be 0. So the first day, what is the current weight? Can you include it? Yes. The second one, 3, can you include it? Yes. Then again you will be adding 3 to it. 6, the weight will become 6. Has it increased more than 18? No. So you can do it in 1 day only. Then what it will become? It will become 10. Then it will become 15. So can you include this 6 in the same day? No, right? Because this will become 21. Let's do this. 21, and the required days will get increased to 2. So since this is becoming 21, we will remove that and make it to the current element. So that is the idea that we'll be doing here. Then again we will add the second element, that is 13. So since it has not increased above 18, the required days will not change. But for the next element, it will become again 21. So we will increase the number of required days by 1, and this will be changed to 8. So at the final ending, what we will check is if the required days is less than or equal to the current days, then we will be returning true. If not, we will be returning false. So that is the idea of this magical function. So here's the code for the magical function. So initially we will be having required days is equal to 1 and the current weight will be equal to 0. And we will be checking whatever logic I spoke about, right? We will be increasing the current weight, and if the current weight is actually greater than the capacity, what we will be doing? We will be increasing the required days by 1 and we will set the current date to I, this particular element. And if the required days is greater than the number of days that is available, we will return false. If not, we will be returning true. So these are the 3 inputs that we should be passing to this particular function. That is weights. We have to pass the weights and we have to pass the number of days and also the capacity of this particular ship. Okay, now let's talk about the pseudocode of the original problem. That is, we will be having a left and a right, and we will be having answer initiated. So what we will be doing, we will be checking if it is possible with mid number of days, whatever we will be getting, and we will be checking if that is possible or not. If it is possible, we will reduce the right to mid minus 1, else we will be increasing the left to mid plus 1. So that is the idea. I will get into the code part. So before getting into the code part, actually 92% of the viewers of my channel haven't subscribed to this channel. So if you are one among them, please do consider subscribing the channel if you are learning and enjoying the videos. The second thing is, just like in this problem, we discussed a particular pattern, and if you learn this pattern, you can solve 8 to 10 problems. Similarly, in this placement series or interview series, I will be talking about patterns and not just about problems. So if you are interested, please do have a look on that. So this is the code of the binary search that we'll be using. That is, we will have a left and we will have a right, and the left and right will be changed here. What is the left? The left is the maximum weight, like we discussed initially, right? That is, you have just got 1 day, so that will be our left. That is the minimum quantity of the ship, the capacity of the ship that is required, and the maximum or right will be equal to the sum of every element. So once you have got that, you will initiate the answer to the worst possible answer, that is equal to the maximum. So that is what we have initiated, and at every step this answer gets changed to either mid or it doesn't get changed. So finally, after all this, we will be returning the answer. So this is the final code of both the functions that is combined. So thank you for watching the video.